Very important concept. Okay, so you gotta make sure you are familiar with normal CDF and inverse norm. I will explain what they do. Okay, page 32. Use these when the values do not appear on the graph. Okay. You'll notice that questions will ask you for, what percentage of, students scored higher than a certain mark. You'll notice that it doesn't show up at the bottom of your bell curve. Okay? That's when you have to use this one. The first one I'm going to introduce to you is called normal CDF. Make sure this is on your study sheet. Okay, this part right here. Normal CDF. And we've got a lower limit, an upper limit, and a standard deviation. So how many entries are there? Look at these commas. Make sure they stand out. There are 3 commas, right? So you need 4 entries. Make sure you make a note of that. Normal CDF needs a lower limit, an upper limit, the mean, and the standard deviation. Okay, always. What does it do? It will calculate the probability of data points existing between the 2 values. The answer is given as a decimal. Okay, it is a decimal. So we multiply by 100 to get the percentage. We need 4 entries separated by commas. Morning. Page 32. And this is the, I'm going to use red and green, or pink and green or something like that, but the lower limit is left side of the curve, and the upper limit is on the right side of the curve. Remember that if z-scores are given, this is very important. Don't forget this one. If z-scores are given, then the mean is 0 and the standard deviation is 1. So I don't need to tell you. So if I give you a z-score, you immediately know that the mean is 0 and standard deviation is 1. This goes way back. Remember, the z-score under the mean was always 0, right? You're with me? What are you talking about? I'm just waking up. Page 25, you don't have to go there right now, just look up. The mean, right, the mean value has a z-score of 0. Right, so the mean is 0, and how much am I going up by if I'm talking z-scores? There's 1, right? It's always a standard deviation of 1. So that's where this comes from. So sometimes students are like, if I give z-scores, they're like, what's the mean and standard deviation? You know, it's 0 and 1, okay? So assume that the mean income per household in a city is 45,000, and the standard deviation is 15,000. We just did the AC, right, where that was the case. So this is your mean, and this is your standard deviation. It's asking, what percentage of households earn between 32,000 and 65,000? Okay. Do you see 30,000? I already made the bell curve for you. Do you see 30,000 anywhere on the x-axis? You don't. But where is it approximately? It is approximately right there. Okay? That's my lower limit right there. That's 32,000 is right about there. And what is my upper limit? 65, correct? Whereabouts is 65? Right about there, correct? So I would consider this the lower limit, and this is the upper limit. And we want everything in between, okay? We want that the percentage that is between the low and the upper. And guess what? Okay, you cannot. Some of you might say, oh, 65,000 is right in between 60 and 75 or somewhere in there. I'm just going to split the percentage in half. You cannot do that because look at the curve, right? It's not, this thing is not a rectangle. So you can't do that. You have to use Normalcdf. So all I'm going to ask you to do, if you're using Normalcdf, is to tell me the entries. So in this case, the lower limit is 32,000. The upper is 65,000, followed by mean and standard deviation, right? So the mean is 45,000. The standard deviation is 15,000. And I will multiply this by 100 eventually because I want percentage. Now, let's practice. I would have this on my study sheet as well. I kind of skipped it. But this is what you press to get to Normalcdf. So let's do that together. So I'm going to press second, and then you see variables, vars. If you look up and you can't find it, it's right next to clear. Vars is right there. So you go vars, and don't select PDF, you select CDF. If time allows, I will show you how to use PDF. It's actually pretty cool, but CDF is all we need. So hit enter, it calls it to your main screen, and then just type in those values and make sure you have them separated by commas or else it will complain. Okay. You hit enter, and there it is. So that'd be 0.7157, and that keeps going, and we multiply that by 100. So leave that on your screen and just multiply your answer by 100, and there you have the percentage. 71.57% of households earn between $32,000 and $65,000. Yeah, so Normalcdf essentially does what you used to do, except for you don't have to add up all the percentages under the curve. It just does it for you. Very exact, okay? So listen carefully to this part. We used to use the graph, correct, to come up with these percentages. If you were to go back and use Normalcdf to find the percentages, you would be off by a bit because we were just estimating. This is an exact way of finding it, okay? So don't think that that's wrong what we've been doing, but sometimes we just use estimation tools. By the way, no data ever is perfectly symmetrical. Like we just say, oh, it is normally distributed, like there's some properties here. And what are the three percentages we think of when it's normally distributed? 68, 95, 99.7. Okay, if we observe that in life, we're like, oh, it's normally distributed. We can apply what we've learned here to it. Okay, let's keep going. What percentage of households earn more than 75,000? More than 75,000. So it's basically saying, can you rewrite this? It's saying 75,000 or more. Okay. Sometimes rewriting it helps students figure out what's happening here. So are we given a lower limit or an upper limit? It's a lower limit, right? 75 and then anything above it. So there is no upper limit in this case. Where is the 75,000? It is right here. Okay. And so in this case, we want anything from there going up more. 75 or more is right there. So this is, what is this? Lower. I'm just going to say lower here. So guess the way around this is as follows. Normal CDF. You would go 75,000. And depending on who's teaching you this course, we'll do this slightly differently. I just tell you to pick a really, really big number. So like a 1 million would be just fine here. Make it so big that it's obvious that it wouldn't even fit on my graph, even if I were to continue to like 4 or 5 standard deviations. So I will just make a note here. Pick large number. Okay. What do I mean by that? I think I need to be specific. If this had been how many people make more than $1 million, would it be smart to use 1 million here? No. Then you should have used 10 million or 100 million or something like that. So you have to base it on your situation. Okay? And what's our mean and standard deviation? Mean is still 45,000 and the standard deviation is still 15,000. We're going to multiply that by 100. Just by observation, what do we expect to get? 2.35 and 0.15, that's 2.5%, correct? Let's see if that's actually true. I'm just going to copy paste. No. I'm going to go get the CDF one more time here. You go 75,000. And then we're going to go 1 million. And then 45,000, 15,000. Let me see if this is safe to say. Double the number of zeros that are in the question. Then you're for sure going to get a big number, right? So if there's 3 zeros, 6 zeros. That's going to probably do it for you. So that's what we get. We get 0.02275 something. We multiply that by 100. That's 2.28. So what's going on? It's supposed to be 2.5. I'll just tell you, we go by this. Okay, this is more accurate than our estimation tool. I just needed you to get used to that before moving on. Okay. So basically, I don't know. I'm going to use a different color here so you're not mixing. But I'm just letting you know that all of this, right? All of that is represented by this percentage-wise. So it's not a whole lot of families households that make more than 75,000. It's a very, very small percentage. Okay. What percentage of households earn less than 39,000? Rewrite it. 39,000 or less. Normal CDF. What is this asking for? It's basically asking for, where's 39,000 approximately? I would say right about there. Right, my 39,000 goes there. And that is an upper limit. Correct? That's like as high as I want it. I want 39,000 or less. So you want all of this, the percentage that is to the left of that. So what do you think I'm going to do for my low limit? Because we want to make sure we go as far out as possible here. We use -1 million in this case. And then you pick your upper limit, and mean and standard deviation are still the same, times 100. So pick small value, okay? A negative is is a very good way of going about it. So let's enter that. Second vars, CDF, negative 1 million, 39,000, 45,000. Watch your zeros, okay? Don't, one too many and you're in trouble, right? When it comes to the actual values. It's 0.3445 something. 0.34457 times 100, and that's 34.46% of households. So this is normal CDF. This is how you use normal CDF. The easiest case is when you get an upper and a lower limit. So I'm just going to recap here, right? Sometimes they tell you exactly between these two values, you know to just enter them like that. When it's more than or less than, that's when we get in a bit of trouble. That's when you need to come up with the value here. So in this case, we have to pick a large number. Can I say this? There is technically no upper limit, but the calculator needs an entry there. So you must come up with a big number. In this case, we didn't have a lower limit, so you must come up with a lower limit. Okay, so that's the key here for those ones. Let's go to 33, and this is finding percentages under the curve. Let's go to 33. That's the inverse norm part of today's lesson. It's the second part that we use. And also, this is study sheet entry. Inverse norm needs percentage below the value you're interested in, the mean, and the standard deviation. So that doesn't change. You need 3 entries. And I feel like I still didn't make that change. I wanted to make a change on the booklet. Can you please write this down on your study sheet in particular? This has to be as a decimal. So we're talking about percentage below the data, the point that we're interested in, but it needs to be stated as a decimal, so make sure you have that. Oh, you can't see that. There you go, now you can see it. So make sure on your study sheet you make a note of that. What does inverse norm do? What does it do for us? It will calculate the actual value, right? Calculates the actual value along the x-axis we're looking for. So it could be the actual height of a person, the actual weight, number of days. And before we get going, remember that little concept here. What's the area under the entire curve again? The percentage or area? 100%, okay? So almost try to just look at the problem right now. So if I were to tell you that 35% of people earn more than $50,000 per year, then I want you to think of it being 100% from end to end. If 35% make more than 50,000, you got to imagine the line being above the mean. Why? If you were right in the middle, what would be the percentage above and below you? 50 and 50, correct? If I have 35% of families earning more, I need the 35 to be here, okay? What does that tell us about the percentage to the left? Because this is important right here. If this is 35, then this would be 65. So I'm just going to show you here. Okay, I'm going 100 minus 35 to make this 65. So inverse norm does not care about percentage to the right. It only cares about percentage to the left. So I'm going to highlight that part. Okay. So, in other words, 65% earn less than $50,000 a year. Okay, so that's the important part. Let's try one more here. If I were to tell you that 42% of students spend less than 15 minutes on their homework, just a guess. 42% spend less than this. If I put a line right here, this would mean that 50% of students spend less than that. So you need to have it just slightly over here. And this is the 15-minute mark. And this would be 42%. 42% spend less than 50 minutes. This, in fact, is exactly what we would want to use inverse norm. There's no need to figure out the percentage anymore. Okay. And remember this. To the left is less or shorter. Okay. To the right is more, takes longer, stuff like that, right? Like, so you got to remember the dynamic there. So this is what I mean. Listen carefully. This is the percentage that I mean inverse norm needs. Okay? And it will spit out whatever x value goes with it. So you're not finding percentages, you're finding actual values. So here it is. And then you're going to practice a few here. This income, doesn't know which one, would have 30% of household earning less. So they want this income down here. Question, would you put the line here? This is just for reference. This is not to scale. Would you put it here? Don't write this down yet because this is wrong. If you had this, then you would have 30 here, right? Earning more. You want 30%, it looks more like this. Does this look like 30 would go there and then this would be 70, correct? We don't care about this one. We only care about the 30. So we're asking what income would have 30% of families earning less than that? Okay? So we use inverse norm. And we put in 0.30. So we turn the 30% into decimal, followed by the mean and the standard deviation. We're still talking about 45,000 as the mean, and 15,000 is our standard deviation, right? So this is the mean, this is the standard deviation. It's still continuing from the previous page. So let's go and figure this out. Grab your TI-84s, and you simply press second vars again, and now you're using inverse norm, the third option. And you just type in 0.3 or 30, it doesn't matter. 45,000, 15,000. There it is. Where now inverse norm gives you, in this case, the dollar amount, okay? The actual dollar amount. So if you made $37,133.99, right? That income would put you in a place where 30% of families earn less than that. Okay? So this is the income that kind of indicates to us along the x-axis, right? That would be like the line. It would actually represent where does that line go where 30% earn less, 70% of people earn more. Except for this, inverse norm doesn't care for this. It only wants that. Okay? Okay, let's do a couple more. Hopefully you can wrap your head around this. An income of question mark, so we're going to figure out what that dollar amount is, would place a household in the top 20%. What does that mean? Let's figure that out. In the top 20%. When you think of top 20, do you think this end of the curve or this end of the curve? Left or right? Right. Top 20 is like on the right. Top 20 is over here. So you almost want to think my line is here somewhere. This is 20, correct? And the top 20. Do we care about the 20% here when it comes to inverse norm? We do not. We want to figure this one out. By the way, if you know that, if you see this at two mark question, it is most likely this, that you have to do extra work. If it's just flat out inverse norm, it's 1 mark. That is the one we want. Okay? So we take the 20, we subtract it from 100, and then we get our 80. So this is the top 20% of income earners would be there. This would be what? Bottom 20%, or right? Bottom 20%, and you're thinking more this end of the curve. So let's use inverse norm for this. 0.8, and then we go 45,000 and 15,000. Let's figure that out. So no multiplying by 100 here, okay? That's only for normal CDF. I'm just going to copy paste in this case. If you can, copy paste, and I'm just going to change that to 0.8. Right? And then hit enter. And that's 57,624 and 32 cents. So that income is kind of like the line, okay? That is the number along the x-axis where you have the 20/80 split, okay? Scratch, right? Question. You're with me, right? I know this isn't super exciting. I know that. Why wouldn't I use normal CDF here? Why am I not using normal CDF here? Because sometimes you will have to choose. Does it ask you for the percentage of people that earn between these incomes or anything like that? It doesn't. Okay? So if it's actually asking for the amount and it gives you some sort of indication of percentage, you want to use inverse norm. Let's do one more here. Let's see if you can figure this one out on your own. I need you to wake up a little bit. Try to answer this question. It is inverse norm. I'm not going to trick you on that one. It is inverse norm. Can you write this out and have the correct 3 entries in there? By the way, the last 2 you already know, mean and standard deviation. You just need to figure out the 1. Try to figure that out a minute or less. Okay, let's see if you can figure that one out. %45% of households earn more than this. I don't know if this helps you, but if you were to put the line in the middle, this would read 50% earn more. You want it to be more over here, right? This is the line on the curve, and I will not provide this every time. You can quickly make one for yourselves. 45% earn more, therefore 55% earn less. And this is the number you want. Okay? So 0.55, 45,000, 15,000. And you get, why is it not on my key? Hold on. 46,884.92. That's what you should be getting there. Okay. Okay, I'm gonna ask you to try this, and it's just gonna have to be, trial and error maybe at first. So 34 to 36, I will post the answer key. Let me just do the graph with you because I don't want you to spend too much time on the graphing part. Let's go to 34. I'm pretty sure you remember how to do this. This is for reference purposes only. Okay? What does it say here on 34? What does it say right there? Use technology to answer the following. If I tell you to do that, right, you have to use the TI-84. Don't be using the graph. Okay, don't be using the graph to answer. That's just for you to A, remember how to do it, and B, so you have a reference point if you want to go check if you're doing things right. So we find the middle. I make that a little longer, and then I use every 2 centimeters. That's 1, 2, 3, 1, 2, 3. So 3 going either way. I go to the middle and I make a big dot at the top, and then I just slant it down. Same here. Slant it. Put the numbers down. We're talking potato chips, and the bags weigh 250 grams. So maybe right away you go weight in grams. Label that. So in our standard deviation, thank goodness it's 5. So it's just 255, 260, 265. So fairly straightforward here. And then slice it up. So if I ask you for a nice graph, make sure you take your time. Okay, and write it, fill it in with all the pertinent information. Success? Did you find it? Uh-oh. And then z-scores. That's the fun fact of today. I speak German. So you can imagine a German, instead of saying the scores, someone saying Z scores, right? And that's the joke for today. All right. We've got all the percentages, we've got everything, Z scores, everything is good. And now I want you to use technology to answer these questions. I will just let you swim on your own for a bit. There will be questions where you might have to find different tails and then add them up. But I will leave that up to you right now. Make sure you try it, because I am going to circulate. I will also post the answer key. So if you're using your phone, make sure you use it to check the answer key. And if you need to listen to music, sorry, I'm okay with that as long as it's not distracting you, all right? All right, because a lot of you had really good questions, and that's what I mean. Like if you go through it, sometimes you have this aha moment. 34 bottom. Bags, make sure you listen, okay? I know some of you already know what I'm talking about. Anything that's less than 239 or more than 262 is being removed, okay? So you got to think of your bell curve. This is 239, this is 262. So we're getting rid of the tails here. There are two strategies on this part. You can find a normal CDF for each one of them, add them up, or you can do a normal CDF between these, right? Find what that is and then go 100% minus the middle to get the tails. Make sure you practice that. My key has that, okay? So if you're wondering what my key has done, check it, please. So make sure you try all the questions, all right, guys? Thank you.